Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 10. We'll cover questions 46 to 50 in this episode. For questions 1 to 45, please refer to previous episodes of this series. Let's get started. Question number 46. A business developed a meal ordering application that collects and maintains user data for future research. On an Amazon EC2 instance, the application static frontend is installed. The frontend application communicates with the backend application, which is hosted on a different EC2 instance. The data is subsequently stored in Amazon RDS by the backend application. What should a solution architect do to decouple and scalability of the architecture? The problem description that we have here is there is a business, say like Just Eat or Uber Eat, and they have developed a meal ordering application, and that is collecting and maintains the user data for future research. They have a front end, which is a static front end and deployed on Amazon EC2. And the backend is consists of compute on Amazon EC2, and that is communicating with Amazon RDS. So that's the overall architecture. The problem on hand for solution architect is to decouple this architecture and make it scalable.
So let's look at the solution overview. First of all, there are two requirements, as we said. One is scalability, another is decoupling. Front end is currently stored in EC2 instance. I think that's a waste of an EC2 instance. It's a static front end. We can store it in S3. So that's the first thing we will do. It would help with the scalability, and it's going to be much more cost effective as compared to using an EC2 instance for storing static content. The second requirement here is that we need to decouple the application. And for decoupling, I think the best solution is we can use SQSQ. SQSQ will receive requests from front end, but we need something there to handle the requests, and we will need Amazon API gateway. So your front end here would post requests to SQSQ, and those will be queued here using an API gateway. And in order to further improve the scalability, what we can do is let SQS process the request, and those would then go to Amazon RDS for updating database. But the overall backend instance, then we can put it in an auto scaling group to further help with the scalability. So that's how the solution would look like. The key elements of the solution from my perspective are scalability and decoupling, which is around S3, SQSQ, and putting all the backend instances in an auto scaling group. Amazon API gateway is something that we have added here because I believe we need something there in order for front end to post the request to SQSQ. Let's see what we will have in the actual question in terms of options, and any option that is closer to what we have just done here, we can select.
What we have in actual options, we have the option that we have just created. Yes, it does. So option D is that option. Let's go through other options and see why those are not accurate ones. So first one says use Amazon S3 to serve front-end application, which sends requests to Amazon EC2 to execute the backend application. The backend application will process the data. So the first option is basically just get rid of EC2 for the front end and deploy the static application in Amazon S3. Now that will take care of initial scalability from a front-end perspective, but the overall application is still tightly coupled. It's not decoupled or loosely coupled, and it will have an overall issue scaling this solution. We have not done anything in this particular option with the backend application, and that's where the most of the performance and architectural elements of whether it is tightly coupled or loosely coupled will come in. Option B then says use Amazon S3 for front-end application, which is similar to option A. And for backend, then what it is saying is let's write request to SNS topic, and Amazon EC2 will subscribe to it and then update the data in RDS. Now, SN is for notification, not for a request response interaction where you're trying to decouple the application. Additionally, subscribing EC2 instances directly to an SNS topic can be insecure and very complex. So this is not a solution for doing transactional update. It's not the correct application. The third option says keep EC2 to serve the front end and write requests to an Amazon SQS. Place the backend instance in an auto scaling group and scale based on the queue depth to process and store the data in Amazon RDS. So in this case, what they're doing is front end is same, EC2, no change there, and backend is being replaced for SQS. And then put in auto scaling group. Now, SQS is suitable for decoupling, but using an EC2 instance for front end will introduce single point of failure and will limit scaling flexibility. And I also don't understand how you're using SQS and auto scaling in terms of writing data to RDS. Like the option doesn't explain how the database updates are going to happen. Anyways, there are multiple issues with this option. So option C is wrong. So that leaves option D for us. We have already done a detailed analysis of this particular option in solution overview. We'll use S3 to serve static front end. We will use an API gateway and an SQS queue to decouple the application. The backend instance will be placed in an auto scaling group and scale based on the queue depth to process and store the data in Amazon RDS. So overall solution will be, we'll use S3 for front end, and it will send request to Amazon API gateway, which writes the request to an Amazon SQS queue, placing backend instance in an auto scaling group, and it scales based on the queue depth and to process and store the data in Amazon RDS. That's it on this question. Let's move on to the next question. Question number 47. A business's application makes use of AWS Lambda function. A code examination reveals that database credentials are being kept in source code of a Lambda function, which violates the company security policy. To comply with the security policy requirement, credentials must be safely maintained and automatically cycled on regular basis. What should a solution architect propose as most secure method for meeting this requirement? So if you look at what we have here is we have a scenario where database credentials are kept in a source code of a Lambda function, which is obviously wrong. That's not how you manage your credentials. So there are various options given here. But before we jump into the options, if you have some credentials that you need to manage, so basically got some secrets to manage, you essentially use AWS Secret Manager. And if you look through the options, there's only one option that has AWS Secret Manager, which is option B. And that is the answer for this. But let's go through the other options and figure out why those are incorrect. So first option A says store the password in AWS Cloud HSM, associate the Lambda function with a role that can use the key ID to retrieve the password. Now, while Cloud HSM provides hardware-backed security module, storing database credential directly in Cloud HSM, which is not different to storing database credentials in the code that we have seen in Lambda function. So whatever is the current situation and the answer, they are equally bad in terms of managing secrets. So I think it's a wrong option. So we'll get rid of it. Let's go to option C. It says store the password in AWS KMS, associate the Lambda function with a role that can use the key ID to retrieve the password. Now you can store data secrets in KMS, but it's not primarily designed for managing secrets like passwords. Secret Manager is the service that is specifically created for managing passwords and automatic iteration of the password, etc. So that's a much better suitable service. So option C is wrong. And option D says let's move the database password to an environment variable that is associated with Lambda function. Again, it's no different to basically you cannot have passwords in clear stored in any form of code. It cannot be in the code, cannot be in the config. So it's completely incorrect. You cannot, storing secrets in environmental variable is strictly against the security best practices because it could be, going in logs or obviously could be exposed to potential human error. So that's wrong. The best solution is use the service that is meant for managing secrets and passwords, which is AWS Secret Manager. That's our answer for this particular question, option B. And let's look at the various characteristics and advantages of this particular option, AWS Secret Manager, for this particular scenario. So this service is specifically designed for securely storing, managing secrets like passwords, API keys, and database credentials. It provides several security features. So it provides encryption at rest. Secrets are encrypted at rest using AES 256 with KMS keys. It provides encryption in transit. Secrets can be accessed using IAM roles and policies, ensuring strict access control. Automatic rotation. Secret Manager can automatically rotate secret on daily, weekly, monthly basis, reducing the risk of compromise from static credentials. Auditing. You can track access and usage of secret for better monitoring and auditing. IAM role associating Lambda function with a role that has least privileged access to Secret Manager ensures that the function only retrieves the credential it needs. So these are the advantages of this overall solution. So this is the perfect answer for storing secrets in an AWS scenario. That's it on this question. Let's move on to the next question. Question number 48. A business intends to utilize Amazon S3 to store sensitive user data. Internal security compliance requirement demands that data be encrypted prior to being sent to Amazon S3. What recommendations should a solution architect make to meet these requirements? So if you look at here, the keywords are Amazon S3 is storing sensitive user data, and security compliance requirement demand that the data needs to be encrypted prior to be sent to Amazon S3. And this is the major keyword here. First, wherever the data is, which is with business, they need to first encrypt it and then send to Amazon S3. Now, this is where you will get your answer. So if you look at and focus on the keyword here, which is we need to send first encrypt the data and then send. So we are talking about obviously encryption at rest, but that encryption happens on the client side. So any option that involves server side is definitely going to be wrong. So option A is a server side encryption. Option C is also server side encryption, and both are going to be wrong. So that leaves us with only option B and D. Now, option B is a client side encryption as well as option E is client side encryption. But if you see in case of option B, we are using Amazon S3 managed encryption key, which is not a good option. Whereas option D is using the master key stored in AWS KMS. So that's the correct answer. Client-side encryption with AWS KMS master key ensures that data is encrypted before reaching S3, meeting the compliance and offering increased control and portability and privacy. Even if S3 is breached, attackers cannot decrypt data without the master key. So this is the best, available option from what we have here. So as we have just seen, we've ruled out anything that is server side. So that's why option C and A have gone. And B is gone because we have a better option, which is master key stored in AWS KMS for encryption, which provides better security control. So that's our answer. Option D, client-side encryption with a master key stored in KMS. That's it on this question. Let's move on to the next question.
Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you have not already done it. Thank you.
Question number 49. A business is evaluating various options for recollecting, processing, and storing data about how people utilize their services. The business aims to provide an analytic capability that enables the organization to easily acquire operational insights using regular SQL queries. The solution should be highly accessible and adhere to data tiers, atomicity, consistency, isolation, and durability, which is called ACID requirements. Which solution, if any, should a solution architect suggest? So what are the keywords here? We need a database solution which has analytical capability, uses SQL queries, has to be highly accessible, and has ACID properties. So if you go by this rule, then option one, which is option A, Amazon DynamoDB, that's not an SQL database. It's a no SQL database. So we can rule that out. Option B, which is a graph database. Amazon Neptune is a graph database, and it's an overkill for simple operational data. And it also doesn't directly address the need for SQL queries. So option B is wrong as well. Then that leaves us with option C and option D. Now, option D is PostgreSQL on Amazon EC2. Now, why do we want EC2 in this case? Managing this on EC2 introduces complexity and eliminates the benefit of having a managed service. I have told you many times, the way you should choose an AWS option from the given available option is you should always go for service that is meant to do a particular job, purpose built for a particular job. You should always go for managed services. You should go for serverless options so that your operational overhead is less, and you should go for less number of services, because when you have only one service in option across various options, then you should always select the cheaper solution if it is doing the job. So in that hierarchy, why do we need EC2, which is not a managed service? In fact, with this option, it might not even offer the same level of high availability and ACID guarantees as RDS. So that's our answer effectively, which is option C. Post, we rule out, option D for the justification we have just discussed. Option effect for this, it supports SQL. It has ACID properties. It is highly accessible when you are doing it in a multi-AZ design. So the availability is great. So that's our answer. Let's analyze this option a bit more in detail in terms of what advantages it has. So the first one, which is a requirement, which is SQL support. MySQL in RDS supports SQL, allowing easy querying for operational insights. It aligns with the business requirement. High availability. So this deployment is going to be multi-AZ, which ensures high availability and redundancy in case of failures. Asset compliance. RDS is asset compliant, so we don't have to worry about that. And we are using a managed service, which is Amazon RDS in a multi-AZ design, which means we do not have unnecessarily management overhead, operational overhead. So perfect solution in the given circumstances. That's it on this question. Let's move on to the next question. Question number 50. Recently, a corporation created its website in order to deliver information to its worldwide user base. The firm wishes to store and speed the delivery of static material to its consumer via the usage of Amazon CloudFront and an Amazon EC2 instance as per origin. How should a solution architect maximize applications high availability? This is a trick question, first of all. So whenever you see static content and you want to deliver it to worldwide user base, we have done exam tricks where you go for CloudFront, S3 plus CloudFront as your solution. But if you look at the requirement on the last line, it says we need to maximize applications high availability. Now, availability is something different. S3 plus CloudFront is going to help you with the performance, latency, making it highly accessible from an performance perspective, but that solution is not going to increase your availability. So you need to be careful while reading such questions and look at actually what has been asked as the problem. So now we have to look for any solution that is going to make this overall situation a highly available one. So we are looking for something like multiple deployment, adding redundancy, multiple zones, multiple regions, etc. So that's the direction we have to go in. So first option is definitely not doing nothing with availability. But let's read this. So it says use Lambda at Edge for CloudFront. Now Lambda at Edge can handle some kind of dynamic content, but it's not ideal for serving static content, first of all, and it wouldn't address the core issue of single AZ. This is in a single AZ solution. So this answer is incorrect. Option B says use Amazon S3 Amazon S3 transfer acceleration for CloudFront. Again, this will speed up the data transfer from S3 to CloudFront edge location, but it's not going to do any benefit for availability. So option B is wrong. Option C and option D both says that let's configure EC2 in a different availability zone, and option D says let's configure uh, another EC2 instance as part of original server cluster. So in both the cases, there is an additional EC2 instance being added. So these two options are at least doing something in the direction of adding some redundancy and increasing the availability of the solution. But if you see option D says, let's add the EC2 instance in the original server cluster in the same availability zone. So if you're adding it in the same availability zone, then it's not going to help much with high availability. Placing both the instances in same AZ, so a failure to that AZ would take down both the instances. So this is not a good answer. Whereas if you look at option C, then over here, the second EC2 instance is being added in a different availability zone. So that means if your current availability zone crashes or is not available for any reason, then you at least have a redundancy in another availability zone. So this is much better solution in terms of increasing the availability of the solution than say option D. And I believe this was the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you. This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.